Hi there, this is Math 148, section 10.3, which covers using the first derivative and second derivative to find optimization in business and economics. These are a lot of applications to business and economic examples. So here are some of the bullet points of things that are covered in this section. They have problems where you're finding the maximum or minimum on some limited range. So instead of finding the maximum or minimum in general, they say, oh, but they'll only work till 9 hours or something. They put a limit on the range, and you have to deal with that. Finding the average cost, so the function that they use is this C bar of x. The average is equal to C of x divided by x, and if you are taking a business statistics class, this is the mean, because you're taking the function divided by x. It's the mean. It's not really an average. There's 3 types of averages, a median and a mode also. That's statistics. We don't get to play with that. The cost function, in case that they give you the average cost, you can find the cost function by taking the average cost and multiplying it by x. I'm just blowing through these formulas so that you can see them once before you start working on your homework. And the revenue function, R of x, is equal to P times x, where x is the number of units sold, and P is either the price or the demand in a monopoly. And profit is given by revenue minus cost, and this one is also a Math 116 concept and a little bit intuitive if you think your profit is just how much money you're taking in minus the cost. And there's some really good examples in this section, so just look at the examples that they go over and then start going after your homework. But I wanted to work through one of your homework problems because it's particularly challenging and quite clever. So here I've written it out for you. This is question 33 on page 673. A company handles an apartment building with 50 units. Experience has shown that the rent for each is $7.20 a month. Ha ha ha, that's obviously not Seattle. You can't even get a room in Seattle for $7.20 a month, regardless. And if the rent is $7.20 a month, all 50 units are full. But 1 unit will be vacant for every $20 increase in the monthly rate. So they just came up with that. Just go with that for right now. If the monthly cost to operate the apartment building is $12 per unit per month, I'm assuming, what rent should be charged to maximize the profit? So it's an interesting question, and I'm going to do it on this board here. So this is question number 33 in section 10.3. So we're going to let x is going to be the number of vacant units. Vacant units. And here's what we know. We know that our total profit, we want to maximize the profit. We want to know what is the rent going to be that maximizes the profit. The total profit is the revenue minus the cost. Well, we don't know the revenue and we don't know the cost function, but here's what we do know. The revenue, how much money you're going to bring in, is going to be the rent that you're charging times the number of apartments that are rented. Number of apartments that are rented. Does that make sense? If you're renting 50 apartments and they're charging $100 a month, your revenue is 50 times 100. So in this case, the rent that you're charging, this is a tricky piece, is $720 plus $20 times x. So hold on, I'm going back to the problem for you. Right here, experience has shown that 1 unit will be vacant for every $20 increase in the monthly rate. So you take $720 plus $20 times each one that's empty, and that's the rent that you're charging, times the number of units that are rented is 50 minus x. It's the total number minus the ones that are vacant. So that right there is your rent rate, and that right there is the number of units that people are living in for that month. Okay, so your revenue function of x, is going to be equal to, I'm just going to leave that this way right there. 720 is 720 plus 20x times 50 minus x. Okay, the cost function, how much does it cost you? So you have some cost of x that is apartment manager fees, light, utilities, whatever, and that's going to be $12 a month times the number of units, 50 minus x. And that piece, the cost function, comes from right here. if the monthly cost to operate the apartment building is $12 per rented unit. So the cost to operate it is 12 times the number of rented units, which is 50 minus X. So where am I going with all this? I have the revenue function, and then I have a cost function, but what I really want to do is maximize profit. So profit, the profit function, is going to be the revenue function minus the cost function. So in this case, it's 720 plus 20x, I'm not quite done, times 50 minus x, all that's the revenue function, minus the cost function, 12 times 50 minus x, like that. And all of this, I'm going to simplify it in one step. I'm going to not go over multiplying this out and pulling it through. But when you do all that, you get negative 20x squared plus 292x plus 35,400. Okay, so this right here is the profit function. And again, I multiplied this out and then subtracted this piece. And I wrote this out in the homework, so you can look at that more detailed if you want information about how I got that. So the profit function, x is the number of units that are vacant, looks like this. So in order to maximize the profit, we're going to take our first derivative, do this thing that we did in section 10.1. The first derivative is negative 40x plus 292. This is going to be equal to 0 when x is equal to 7.3. That's 292 divided by 40. Okay. So because this is an application, we can't have 7.3 units vacant. We have to have either 7 units vacant or 8 units vacant, unless you're renting a little bit to a very large rats, which is unpleasant to think about. So another thing to think about, we have this number, is this a maximum or a minimum? So make sure, here's the check, the maximum check. You could note that the second derivative, p double prime of x, so if I take the second derivative of this, that's negative 40, which is less than 0. It's a negative number. So that tells us that the function is concave down everywhere. It's just a function that looks like this. So if we have a point here, 7.3, that must be a maximum. We're trying to maximize profit. Sometimes you want to minimize cost, and you want to maximize profit. So again, we can't take 7.3, so let's look on either side. Let's see what happens at 7 and see what happens at 8. Okay. So when x equals 7 units vacant, the profit, when x equals 7, is equal to, just equal. You plug x equals 7 into this equation, 7 right there, and you get 36,464. I sort of skipped ahead, I just gave you the answer there. And when x equals 8, if we plug 8 into this equation, if we plug 8 into x squared, 292 plus 8, the profit when x equals 8 vacant units is 36,456. So this tells us that 7 is a little bit higher than 8. 8's a little lower. So we want to maximize our profit at 7 vacant units. 7 vacant units. So maximum profit at 7 vacant units when x equals 7 vacant units, but that isn't actually what the question asked. If you look at this, it says, what is the rent? What rent should be charged to maximize the profit? Okay, that's okay, because we were saying, I'll go back to this red pen here, that the rent, they're going to charge you $720 a month plus $20 times every vacant unit. Remember, it was in the problem right here. It's going to be 1 unit will be vacant for every $20 increase in rent. So if you want 7 vacant units, you multiply that 20 times 7. So the rent is $720 plus 20 times 7. That's 720 plus 140 equals, yes, $860 a month in rent. So that is the long answer to this problem. which is, what should you charge for rent to maximize the profit? $860. And then as a side note, what is the maximum profit? You're going to get $36,000. So in theory, you could then look at your loan and decide if your apartment building loan is going to, be paid off by this number. But obviously managing an apartment building has many complications, and I'm not sure that you would ever do calculus if you're really doing it, but this is a challenging problem and I wanted to go through it. So I'm going to go over another question from this section, section 10.3, in another video because these problems are long.